Hello, aspiring Java developers. Welcome back to the channel. Today, we are diving into one of Java's most powerful and advanced features, the Java Reflection Application Programming Interface. If you have ever wondered how frameworks like Spring or Hibernate work their magic, or how you can inspect and manipulate code at runtime, then you are in the right place. Reflection allows a Java program to examine or modify the runtime behavior of applications. It is like giving your program X-ray vision and the ability to change things on the fly. In this 5-minute animated whiteboard tutorial, we will explore what reflection is, how to use its core components, look at a practical example, and discuss important considerations. Get ready to unlock a new level of Java mastery. Let us begin. Alright, let us kick things off by understanding the gateway to reflection, the class object. In Java, every class, interface, and enumeration has a corresponding class object that is created by the Java virtual machine when the program runs. This class object acts as a descriptor for the type, holding all metadata about it. There are three primary ways to obtain a class object. First, using the class.forName method with the fully qualified name of the class, which is great for dynamic loading. Second, using the .class literal on a known type, like string.cls. And third, by calling the getClass method on an existing object instance. Once you have a class object, you have the key to introspection. Notice how each method serves a slightly different use case, giving you flexibility based on whether you know the class at compile time or need to discover it at runtime. This class object is truly the starting point for all reflection operations. Now that we can obtain a class object, how do we actually inspect its members? The class object provides methods to retrieve field method and constructor objects, which represent the class's variables, functions, and constructors, respectively. For fields, you can use getDeclaredFields to get all fields declared by the class, including private ones. For methods, getDeclaredMethods retrieves all methods, again, irrespective of their access modifier. Similarly, getDeclaredConstructors gives you access to all constructors. The key distinction here is between methods like getFields, which return only public members, and getDeclaredFields, which return all members declared directly by that class. These returned field method and constructor objects themselves provide further methods to query their names, types, parameters, and even their access modifiers. This granular access is what makes reflection so incredibly powerful for dynamic analysis. Let us put these concepts into practice with a concrete example. Imagine we have a class called secretAgent with a private name field and a private revealSecret method. Normally, you cannot access these directly from outside the class. However, with reflection, we can. First, we obtain the class object for secretAgent. Then, we can get the field object for name using getDeclaredFieldName. Before we can modify it, we must call setAccessible true on the field object, which overrides Java's access checks. Then, we can use field.setAgentObject James Bond to change its value. Similarly, for the private revealSecret method, we get its method object using getDeclaredMethod reveal secret, call setAccessible, true, and finally invoke it using method.invoke, agent object. Observe how the program successfully accesses and manipulates private members, demonstrating the true power and flexibility of reflection. While reflection is incredibly powerful, it comes with important considerations. One common mistake is overusing reflection when simpler, type-safe alternatives exist. Reflection bypasses normal access control, which can lead to security vulnerabilities if not handled carefully. Always ensure you understand the implications when calling setAccessible true. Another pitfall is the performance overhead. Reflective operations are significantly slower than direct code calls because they involve dynamic lookups and boxing-unboxing operations. Therefore, avoid using reflection in performance-critical code paths if possible. Best practices include using reflection sparingly, primarily for framework development, testing tools, or specific scenarios where dynamic code manipulation is truly necessary. Always prioritize readability, maintainability, and performance, and only resort to reflection when no other elegant solution is available. And that brings us to the end of our 5-minute deep dive into the Java Reflection Application Programming Interface. We have learned that reflection allows us to inspect and modify classes, fields, methods, and constructors at runtime. We saw how to obtain class objects, then use them to retrieve field, method, and constructor objects, and finally, how to dynamically access and manipulate even private members. Remember to use reflection judiciously due to its security implications and performance overhead. It is a powerful tool best reserved for specific advanced use cases. Keep practicing these concepts in your integrated development environment, and you will soon master this advanced Java feature. If you found this tutorial helpful, please hit the like button, share it with your friends, and do not forget to subscribe for more advanced Java content. Keep coding, and I will see you in the next video.